Good morning, everyone. Good morning, biology students. Happy Monday. And today I'm going to be explaining part A of our lab. So I'll be walking you through parts of that virtual lab and then prompt you at certain points to go ahead and fill in the information asked in the question. So I'm not going to outright give you the answers, but be sure to be following along and I'll give you some definite hints going forward. All right, so you can go ahead and follow these instructions to find the virtual lab link. And if for some reason on your Chromebook, the Flash Player software does not work, you can go ahead and click this video to find a workaround that will allow your Chromebook to be able to do the virtual lab. All right, so you've already completed the tutorial for your pre-lab, so let's get started. Okay, part A. So we're going to figure out our guiding question, define the problem, hypothesis, and carry out our experiment. So let's begin. So go ahead and click on this link. It will then prompt me to go here. Click begin. You've done the tutorial already, so let's go ahead and hit Cricut. Okay, introduction. This is a program in which you will use the scientific method to solve a problem involving a chirping cricket. Next, you will work from the menu on the left. It will perhaps be best to go logically through the menu first to last, but as a scientist, you are free to work through the problem in any manner you wish. So as you'll notice, you can actually kind of jump around in this. You can click different buttons and go, but I would recommend just doing what we've done here and go in order, do what they recommend. So if you become confused about the scientific method, go back and do the tutorial that was provided. So first, define the problem. On several hikes in the White Tank Mountains, you have come across the same noisy cricket. However, every time you hear him, he is chirping at a different rate. On your first trip into the area, the cricket was chirping like this. So at that rate, on March 21st at 6 a.m., chirping slowly. Several months later, you hike into the same area. To your surprise, you see the same cricket. However, you are puzzled to hear him chirp much faster than before. So on June 21st, he's chirping fast. After you go home, you begin to think about the cricket. Curiosity gets the best of you, and you decide to hike into the area one more time. Unbelievably, you come upon the same cricket. He is, of course, chirping, but he is chirping faster than the first time, but slower than the second. So on September 21st, he is chirping medium speed. Each time you have seen the cricket, he has chirped at a different frequency. This seems strange, so you decide to investigate further. You catch him and take him back to the lab. Once you have the cricket in the lab, you need to define a problem that can be investigated scientifically. Which of the following would be a good statement of the problem? So at this point, you're going to go ahead and pick which one you think is best. So which is it? Is it crickets seem to chirp at different rates? Is there a single factor that affects the chirping rate in crickets? Or I wonder why and how the cricket makes his chirping sound. So this one we actually found in the research, part C. We found they chirp through stridulation, where special body parts are rubbed together to make the chirping sound. So maybe we're not going to pick that one. Now we're down to two answers. Crickets seem to chirp at different rates. And is there a single factor? So we looked at it in different seasons, so we might choose B. Is there a single factor that affects the chirping rate? Why is that chirping rate changing seasonally? So good. That is the best statement of the problem to be investigated. You have now defined the problem that you're going to investigate. Is there a single factor that affects the chirping rate in crickets? Click Next to proceed with the investigation. Let's take a look back at our lab now and see what we can do. So, We have now defined the problem, and we can go ahead and list our guiding question to be investigated. So go ahead and, based on what you've learned so far, do that right now. Since you are not necessarily a cricket expert, you may be unsure of which environmental factor has an effect on the chirping rate of the crickets. Each environmental factor could be tested as an independent variable. So we are now, in the future, going to identify the 5 potential independent variables. So let's keep going in our tutorial. Collecting information. From reading articles and referencing books, you glean the following information. It may or may not be useful in your investigation. Only male crickets chirp. They do so by rubbing one wing against the other or by rubbing their legs against the wings. That's stridulation process. 2, crickets hear with their elbows. Their ears are small discs near one of the joints on the front leg. Number 3, crickets have several chirp patterns. The one we usually hear is the calling song used by males to attract females. Number 4, some crickets are mute. They don't chirp. Some of the mute crickets live in caves. 5, in parts of Africa, cricket songs are believed to have magical powers. Number 6, the male cricket even sings underground. Number 7, crickets belong to the order Orthoptera. This is the same order that includes grasshoppers, gotiidids, walking sticks, and roaches. That is the information you were able to collect. Click Next to proceed with the investigation. All right, so now we're going to really find out those variables. Remember, you have defined your problem as what is the one factor that affects the chirping rate in crickets. So this is a great place to look for a question for that investigation. The laboratory conditions are set up to recreate the field conditions of your last visit to the white tanks as much as possible. So remember, we want to keep as many things constant as we can. So air temperature in the lab is set to 25 degrees Celsius, which is room temperature. Atmospheric pressure is set to be 760 millimeters of mercury. Humidity at 15%. Number of crickets nearby, 5. Wind speed, 2 meters per second. And cricket chirps, 148 chirps per minute. Now it is time for you to make a hypothesis. All right, so for your hypothesis, select the factor or variable that you believe causes crickets to chirp at different rates. So your 5 choices are air temperature, atmospheric pressure, humidity, number of crickets nearby, and wind speed. All right, so we have our 5 possible independent variables right here. So let's go ahead and go back to our lab sheet and go ahead and fill those in. So those are going to be the environmental factors. So I would go ahead and put those in there right now. Those 5 independent variables, things we could change to see how it affects our dependent variable. And now, in order to identify our dependent variable, let's go ahead and look at our prompt right here. So for your hypothesis, select the factor that you believe causes crickets to chirp at different rates. So how crickets chirp at different rates is going to be what we're going to measure, what we're going to observe. That will be the responding and dependent variable. So we can go ahead and put that cricket chirp rate down here as well. So you can just find that by following right along with our virtual lab. Okay, so now in order to know which is the one we're actually going to use, we can actually kind of scroll down to our data. And based on what we have determined in this lab, we have found that atmospheric pressure, humidity, number of crickets nearby, and wind speed all have no effect on cricket chirp rate. As you'll see, wind speed changes, cricket chirp rate stays the same. Number of crickets changes, cricket chirp rate stays the same, and so on and so forth. So the variable that you are going to be using, the independent variable, back up in part A, is going to be temperature. So based on our pre-lab research, we believe that temperature may be the variable that affects the chirping rate. So we don't know for sure, but we know it's not those other ones. So we want you to write a hypothesis for your experiment. Which factor increases cricket chirping in the if-then format? And as a hint, your independent variable is your if, and your dependent variable is your then. So if blank, then blank. So go ahead and write a hypothesis right now related to temperature. All right. So then number 5, identify the control group. This lab does not have a control group. Normal evening temperatures vary from 5 to 45 degrees Celsius. So this is measured on kind of a daily basis. It's not necessarily measured at the same time each day. So there are a lot of variables in this experiment that are things that are going to change environmentally, but we want you to identify at least 3 controlled variables. So think about things that wouldn't change. So go ahead and identify some of those for this case, for this cricket chirping example. And then for number 7, think about why it is important to only test one variable at a time. Think back to what we talked about with our controlled experiments. All right, so and if we just go ahead, you would select your air temperature one. And from here on out, you would collect data. So this will be covered in our next video for part B, data collection. So I think that will wrap it up for part A. So make sure you do questions 1 through 7, and today is Monday, and then tomorrow on Tuesday, we will pick it up with our part B, data and evidence. All right, everybody, have a great day. Take care.